Hello, today we will be looking at functions and how they can relate to other functions. Functions are often defined using sums, differences, products, and quotients in varying expressions, including composites. A function typically is the notion of correspondence, in that typically a set of each x and d, there corresponds exactly one y and r. If you have d, we're saying that 1x here corresponds to one y value in R. You can think of this like books. If you have Harry Potter and the Sorcerer's Stone, you have to forgive my reference, but I do love that book. Let's say Harry Potter and the Sorcerer's Stone, that is X, and that corresponds to the number of pages. Let's say it has 1,000 pages. So we know that Harry Potter and the Sorcerer's Stone corresponds to 1,000 pages. Say we have Harry Potter and the Half-Blood Prince. That book, let's say, has 1,500 pages. So we have Harry Potter and the Sorcerer's Stone, which corresponds to 1,000 pages. We also have Harry Potter and the Half-Blood Prince, which corresponds to 1,500 pages. However, the same element in R may correspond to a different element in D. And so that's saying if you have Harry Potter and the Order of the Phoenix, let's say that also has 1,000 pages. However, we also know that Harry Potter and the Half-Blood Prince has 1,000 pages. So that's how you can have an element in R that corresponds to a different element in D. You might have two different books with the same number of pages, or you can have different books with different number of pages. Now that you understand functions, I have listed out a table with common terminologies and values associated with those terminologies. And then after we go through this table, we will look at an example of each of them. Looking on the left-hand side for the terminology, we're going to start with sum. And this is very, very simple. You're going to think of two separate functions, and then you're going to add them together. So if you have the function f plus the function g, that represents the function f with respect to x plus the function g with respect to x. Next, we're going to look at the difference, and very similar to the summation in that the function of f minus the function of g is going to denote the function f of x minus the function g of x. Similarly, you're going to have the product. You're going to have the function of f multiplied by the function of g. And then what you see here slightly different is the x is outside. However, it's almost like a distributive property in that it's denoted by the function of f with respect to x multiplied by the function of g with respect to x. Quotient, similar. You're going to take the function of f divided by the function of g. Both of those are in respect to x. From there, you're going to do, again, a distributive property, if you will, and you're going to get the function of f with respect to x divided by the function of g with respect to x, in that the function of g with respect to x is not equal to 0, because we know anything divided by 0 is undefined, so therefore we don't want the function g with respect to x equal to 0. The last terminology that we see here is composites. A composite essentially is saying you're taking a function and inputting that function into another function. And the composite is represented by a circle between two functions. So you have the function of f composite the function of g with respect to x. And so again, you're going to take the function of f, and rather than having it with respect to x, you're going to take it with respect to the function g with respect to x. When we go through examples, this will become very, very clear. However, you can really think of this as inputting in a value for x. So say you have y equals x plus 2 and x equals 2. You're going to substitute that 2 into the x and then solve the problem. That's essentially what you're doing here. You're going to substitute all the values in the function f with respect to x with the function g with respect to x, and then you're going to solve. Okay, now that we understand what's going on, let's look at a few examples. Okay, we are going to look at an example for each of the terminologies that we just discussed. So I will go through that table. We're going to start with the summation, then we're going to go with subtraction, multiplication, division, and then we'll do a composite. And to make it easy, we will use the same function f of x and the same function g of x for all of the examples. Looking at the sum, we're going to get f plus g, and that can be rewritten as f of x plus g of x. If we do that, then we're going to take f of x, which in this case is 2x over x minus 4, and then we're going to add g of x, and that is x over x plus 5. And then we're going to solve. If you need a refresher on how to solve the problems that we'll see in this video, I will link a few videos in the description below, and please check those out. Looking at this, what we're going to do is find a common denominator. In this case, we'll take the left side, multiply it by x plus 5, and then the right side, multiply it by x minus 4. So we will get x plus 5, and then multiplied by 2x divided by x minus 4, x plus 5, and then we are going to add. In this case, we're going to take the right side and multiply it by x minus 4, so you get x minus 4, and we multiply it by x, and then we have x minus 4 and x plus 5 in the denominator. Simplifying this will give us 2x squared plus 10x plus x squared minus 4x, and then we're going to have here in our denominator x minus 4, x plus 5. Further simplifying, we're going to get 3x squared minus 6x over x minus 4 multiplied by x plus 5. And then we can factor out this 3x from the numerator, and that's going to leave us 3x multiplied by x minus 6 and divided by our denominator, which is x minus 4, and then x plus 5. And this will be our answer. I like to leave it in its simplest form. Most test answers and most classes will have you reduce it down to the lowest common factor as a correct answer. Okay, let's look at our next example. All right, in this example, we are going to look at the difference. We're still using the same function of f and the same function of g. So we have the 2x divided by x minus 4 for function f, and then for g, we have the x divided by x plus 5. So to subtract, we are going to look at f minus g, and that is also denoted f of x minus g of x. If we substitute in f of x, we're going to get 2x minus x minus 4. And then if we substitute in g of x, we are going to get that x divided by x plus 5. What we want to do here is simplify. Similar to what we did in the last example, we want to get a common denominator. Again, we are going to multiply the left side by the x plus 5, and we're going to multiply the right side by the x minus 4. When we do that, we're going to get 2x, and then we have the x plus 5, and then minus x, and then we have the x minus 4. And then on our denominator, we're going to have that x minus 4, and we're going to have the x plus 5. When we simplify, that's going to leave us with a 2x squared plus 10x, and then we have that minus x squared plus 4x. That's still over our x minus 4 and our x plus 5. Further simplifying, we're going to get x squared plus 14x, and we still have the x minus 4 and the x plus 5. We can take out the x because that is a common factor in the numerator. That's going to leave us with an x, multiply it by x plus 14. And then in our denominator, we have the x minus 4, and we have the x plus 5. And this is our answer. Fairly simple. Again, all we're doing is substituting in the function f of x for what it equals and the function g of x for what it equals, and then simplifying as far down as we possibly can. All right, let's look at our next example. All right, in this example, we're going to be looking at the product. So we're going to take the function of f and multiply it by the function of g. That's also denoted as f of x multiplied by g of x. All right, if we do that, we are going to then just substitute in the f of x and g of x. We will have 2x divided by x minus 4, and then multiplied by x over x plus 5. All right, from there, all we do is multiply across the top. That's going to give us 2x squared over x minus 4 and x plus 5. And that's our answer. Very, very simple. Again, if you need a refresher on how to multiply fractions, look in the description for a video on how to do that. All right, because we have some room here, we are going to continue with our next example. I will just draw a line so we don't get confused. And then what we're going to look at is the quotient. And so in this case, that is the function of f divided by the function of g. And that's also denoted the function of f with respect to x divided by the function of g with respect to x. All we need to do here is substitute in the values for those functions. So f of x, we have 2x divided by x minus 4, and then we are going to divide it by x divided by x plus 5, because that is the function of g of x. From here, we can use our rules of dividing fractions, and this is going to be 2x divided by x minus 4 multiplied by x plus 5 over x. We see here that the x's cancel out because this is now multiplication. We see that we have the same thing in the numerator as we do in the denominator, so we can cancel those out, making our multiplication easy. And then all we need to do is multiply across. So what we have is 2 multiplied by x plus 5, and then we have in our denominator x minus 4. And this is our answer. Again, pretty simple. All we're doing is substituting the values for those functions and then simplifying. All right, the last thing we need to look at is composites of functions. Let's look at our final example. All right, looking at our final example, we are going to be looking at composite. From our table, we're going to use the function of f, and we are going to composite it with the function of g with respect to x, and this can be denoted as f of g of x. And all we're doing is plugging in for the values of x in the function f, we're plugging in the function g. What does that look like? With f of x, we see that we have an x here in the numerator, and we see that we have an x here in the denominator. The function g of x is going to replace each of those x's in f of x. And g is going to go here, and g of x is going to go here. Writing that out, we're looking at the function f of x, and that is 2x divided by x minus 4. And then when we put in f of g of x, that's going to be equal to 2, and then we're going to multiply it by g of x, which in this case is x divided by x plus 5, and then we're going to divide it by, and then we have another x here, which again we're going to replace with g of x. That's going to be x divided by x plus 5 minus 4. Now that we have the function with respect to the function of g and x, or f composite g, all we need to do is simplify. We're going to simplify the numerator. That's going to give us 2x divided by x plus 5. And then we're going to simplify the denominator. And in this case, we need to make sure that 4 has the exact same denominator as the value x divided by x plus 5. And so if we multiply by 1, or in this case, x plus 5 divided by x plus 5 to 4, that's going to give us the same common denominator. When we do that, we're going to get x plus 5, because this doesn't change, and then we have minus 4 times x plus 5, and then divided by x plus 5. Simplifying the denominator, we're going to keep our numerator the same, 2x, x plus 5, and we're just going to work in the denominator right now. We have x minus 4x minus 20, and then divide that by x plus 5. This simplifies down to 2x divided by x plus 5, and then that divides by x minus 4x is negative 3x minus 20, and then divide that by x plus 5. Now with our rules of division with fractions, we get the 2x divided by the x plus 5, and then multiply it by its reciprocal. So we get the x plus 5 on the top, and we get the negative 3x minus 20 on bottom. We see that this term and this term are the same, so they can cancel out. And that is going to leave us with 2x divided by a negative 3x minus 20. If you want, you can take that negative out of the denominator and bring it to the front. Negative 2x divided by 3x plus 20. And this is your answer. So you see, if you write everything out, it's not as complicated as it appears. And there you go. Now you understand functions and how they can relate to other functions when using different terminologies like sum, differences, products, quotients, and composites of other functions. If you have any questions, please post them down in the comments below. If you've learned something, please like and subscribe, and we'll see you next time.